we will do, quiet please. I'm recording this supposedly for 35?
31 and 35.
I can't do them both, I don't think.
31. No, please, Mr. Mayor. Because I actually attempted the whole football time. Please do.
Actually attempted.
Don't do it.
31. I'm sure you wanted to, so.
All right, here we go. 31, quiet please. The radius of the circular mountain is estimated to be 16 inches. Maximum area measurement.
Okay, guys.
All right, is that how you did it? Use differentials to estimate the maximum area in the calculated area of one side. To estimate the maximum area, so that's dA, pi r squared, so it's going to be 2 pi r dr. dA equals 2 pi 16 plus or minus 0.06. Multiply that out. I took the derivative. dA equals the derivative of A times dr.
You're multiplying that.
Correct. So the answer would be plus and minus something. You multiply it out. Now it says approximate the average error. That's when you take your answer. This is like part B. This is like part A. Part A is right here. Part B. Yes, Rachel?
Would it just be positive for the number A as it's a maximum?
Nope. You could go either way because you could be long or short on your radius. 6.03.
Yep.
So it could be off by 0 or plus minus 6.03 inches squared. You could be off by the area. So you take plus or minus 6.03 and divide it, because it says find the average error, by the actual area, pi r squared, and using r as 16, I believe. Yes. So plus or minus 6.03 divided by 16 squared pi. And that'll give you some decimal when you calculate it out. Make sure you use parentheses around the denominator. 0.0075. And now the percentage error is plus or minus 0.75%. Is that even close?
Yes, sir.
Great. So that's a question involving all three types of use of differentials for calculating error, approximating average error, and approximating percentage error. Okay. Which one after this? Was there another one, or is that it?
Yeah, 35.
35.
I believe there is something 35.
One side of the house has a shape square and equilateral triangle. If the length of the base is measured to be 48, with a maximum error measurement of plus or minus 0.1, I'll call that S. So that means DS equals plus or minus 1 inch. The 48 feet, I'll probably convert to inches. So multiply that by 12. Probably, I don't know. What do you get? What's 48 times 12? 526? 576 inches. Okay. Calculate the area of the side. The length of the base measured with the maximum area. Calculate the area of the side. Use differentials. Okay. The area equals the square root of 3 over 4 s squared plus s squared. That's the area of an equilateral triangle. That's the area of a square. I guess I'm just going to put in 576 if I want to keep it in terms of inches. A equals the square root of 3 over 4 times 576 squared plus 576 squared. I don't know. Doesn't look that difficult. 576 squared times second square root of 3 divided by 4 plus 576 squared. Enter. Now if I want to do it in square feet, I just divide it by 144. Because there's 144 square inches in a square foot, right? 12 times 12? Yeah. So you can answer it either way. You can either keep it as square inches, or you can keep it as square feet. Square inches or square feet. I don't think it matters much. Next, use differentials to estimate the maximum error in the calculation. Okay, I don't know. dA, is that right? So that'd be square root of 3 over 2s plus 2s times ds.
Did you get this for the
I took the derivative of a, dropped the 2 out in front. Again, just put in the 12 for the s. Well, this is going to be nifty. Second, enter. 576. Delete. Change this to a 2. Delete this one. And put a times 2. Won't that be what this expression says right in here? And I have to take that answer, enter, and multiply it by point, or just multiply it by 1. That's odd. Yeah, I can actually. I have that skill. Divided by 144, 11.5. Yeah.
So in the back of the book, I'm pretty sure it has like.
Yeah. No, I think you can use this because you got the inch right here. It says what feet? How many? Oh, that's in feet. Yeah, divide by 144. I think meant the other one. The other one's in inches. No, it's not. This one is in inches, and this one's in feet. I thought we established if you divide by 144, it's square feet. Right? Well, how far off am I on the answer? Oh, great. Is that the last of the problem, I hope? Oh, average error. That should be easy. I just take the answer from part A. We're going to do it in feet or inches? Okay, if we're doing it in feet, I'll go with 3301.6. And I'll divide that into 11.46. All you do is type it out. Because I'm on 11.5. And 33.017. I don't know whether to go 1 or 2 decimal places. I'll just go 1. That's just the same thing as dA over A, isn't it? The average error. I have no idea what that is. 347. Thank you. So it'd be the percentage error would be 0.35%. And that's all plus or minus. I think everybody remembers that from the plus or minus in the problem. Okay. Nice. Nice little way of finishing up that topic. Go on to the next fun one. This one, I changed the presentation because I might not. I don't know what my plans hold for me next week, so I'll just start thinking of that. We might do a 5 for 10 or 1 for 10 or something today. I know, that's awesome. Yeah. Yeah, you are. Pretty much. It is 3.6. This is known as the chain rule. Grizz, you gotta learn to focus a little quicker. This chain rule, CHAINRULE, chain rule. That's when you take the derivative of a composite function. Yep. Yep. You're taking the derivative of a composite function. How do you know it's a composite function? Well, for one, in the first couple problems, they actually tell you it's a composite function. The actual function you're looking at is y equals the cube root of of just x squared plus 5. That was bizarre. X squared plus 5. So, you don't know how to take the derivative of a composite function. A composite function is made up of two parts, the inner function and the outer function. You had that in pre-calculus. You wrote it, bless you, as f of g of x. That's how you wrote composite functions. G of x in this case would be the x squared plus 5. F of x would be the cube root of x. In terms of calculus, they don't really use, they do f and g of x a little bit, but they like to stick with dy dx, just like in the average error problems we did. Okay? So if you want to take the derivative of a composite function, it looks like the product rule and the power rule are kind of at play in doing it. If you always forget this, you can always go back to the limit definition. As delta x approaches 0, f of x plus delta x minus f of x, all over delta x. You can do that. So, what this says is, if you want to take the derivative of a composite function, think about it as two different steps. One, you take the derivative of the outside, this is the derivative of the outside, times the derivative of the inside. There is no product rule. There is no plus sign. Okay? And one thing you have to know is when you take the derivative of the outside, the inside doesn't change. It stays intact without being changed. Okay? Now, there's lots of ways of writing it. This is one way. This is another way. F prime g of x times g prime of x. Some people think there's too much parentheses there. Yep. These all mean the same thing. The outside is the cube root of x because it is, if you put this in the TI, it's outside the parentheses. Okay? Interesting. So it's outside the parentheses. So, it'll come back. It should. Yeah, it will. Anyway, if it doesn't, the cube root, parentheses, x squared plus 5, close the parentheses. Some people just look at it how you would type it in a TI to tell you which one's the inside and which one's the outside. There's f prime g of x times g prime of x. People don't really like that one. There's the O prime, I prime, with the I staying the same. It doesn't change. There's the traditional dy, du, du, dx way of looking at it. You can't read it? Sure you can. I know you did. All right. So, the derivative of the cube root of u is the same as 1/3 u to the negative 2/3. The derivative of u with respect to x is just 2x. Okay. This first one says I took the derivative of y with respect to u as my variable. This one, the second one says I took the derivative of u with respect to x as my variable. You don't really write this, you just think about it until you get the hang of it. You won't see me using this maybe for 3 or 4 slides, that's it. And then I go on to writing it the way it's more efficient and quicker. But notice over here, it wants the answer in x's only. It does not want the answer with u in it. Yep.
So that right there is just the derivative of y and the derivative of first term.
Nope, this is everything. This is your final answer. Not your final answer, this is one step to your answer. I took the derivative of y with respect to u. I dropped the 1/3, subtracted 1, and got negative 2/3. Then I took the derivative of u with respect to x, and I got 2x. The derivative of any constant is 0. Yes?
So the g of x is the y equal and the g of x is the u equal.
Right. Okay? So there's 2 different parts where you take the derivative, and this is why the inside doesn't change. What's u actually equal to? X squared plus 5. So your final answer is going to be x squared plus 5. So what's in the parentheses doesn't change on the first derivative. And you multiply it, the derivative of the inside. Now, what's better than a composite function? Yeah, it is a composite of a composite function. Oh, yeah. That's later. But right now, we have to learn how to take some more derivatives to practice. You do, because it's not solving. You're not finding any slopes of any tangent lines yet, or setting equal to 0 yet. You're not finding any equations of lines yet, so you're in good shape. This is just broadening your ability of taking derivatives. You've done trig functions, you've done polynomials, you've done quotients, you've done products, now you're doing composite functions. The best part is going back from dy dx to the original question. That's second semester. Ready? Let's try another one. Y equals u sine u, and u is x cubed. They actually do this in your homework. They start off like this to get you used to the idea. It's 2 derivatives multiplied together. The actual equation, I hope you know, is y equals x cubed sine of x cubed. And during the program today, I was reading the list of students that aren't here but that should have got academic awards that were seniors last year. And I was going through and I was like, remember some calculus good times. And one kid in particular always asked, is this where you use the product rule? Is this where you use always? And I was like, product rule, product. Because there's 2 variables right there, so you're going to have to use the product rule at some point in time in your steps to get your final answer. Okay? So in this case, there's only 1 variable, so when you take the derivative of u, that's not going to happen in this one. But when you take the derivative of y, that's where it's going to happen. Okay? You're going to do it twice right there. You're going to use the product rule. So don't forget, we're going to take the derivative of y with respect to u. Okay, that means y prime. So I end up with 1 times sine of u plus u times cosine of u. That's the product rule. The derivative of the first times the second plus the first times the second. This is f prime g plus f g prime. And there's all these symbols going on. I said, I know. It's like that little tunnel where they turn the money on. It's going all around you. You know, it's hard to remember what's what. But now you got the derivative of u right here. That's 3x squared. Questions on that? Okay. And now your final answer is you just put in the x cubed for u, and then you're done. Let me ask you something before we go into our last step. In this equation right over here, does anybody see any parentheses to tell us it's a composite function? If you're going to put it in the TI, where would the parentheses be? Around the x cubed on the sign, isn't it? You don't know the derivative of sine of x cubed. You know the derivative of sine of x, but not sine of x cubed. So that tells you you're going to use the chain rule for that derivative. Okay? So you put in x cubed and you're done. Yep.
So how did you get 1 sine u plus u cosine u?
Oh, I took the derivative of this expression or equation using the product rule. The derivative of the first term is u, that's 1, times the second, which is sine, plus the first term u times the derivative of sine, which is cosine of u. Okay? So f prime of g plus f, and this is g prime. All right? I know there's a lot going on now, isn't it? It's great. It's kind of like last night. There's so much going on in the world of baseball. They're just tripping on themselves trying to keep up with everything. It was kind of fun, but then it got kind of old after a while. But that's all right. It all worked out for the best. Ready? For the best. And then you put in the U's for your answer. No, it doesn't. That's all right. I have this power. 1 sine of x cubed plus x cubed cosine x cubed all times 3x squared, right? Yeah, then you multiply it out. I think that's what that next step was. 3x squared sine of x cubed plus 3x to the 5th cosine x cubed. Well, I will, since people don't know right now, because as soon as I hit the button, it's going to have both on top. You know, it's going to be like overlaid. That won't look very nice. Ready? I think that was fun. Yeah, see, I think that's what I just did. Yeah, no, it's not. All right. Good thing we're not reading that. Here we go. This is your own, first with no hint, no holding of the hands, your first ability to take your first steps using the chain rule. This is a proud moment for me. She got the camcorder.
There's no second term there.
What are you looking at?
The last one we had like y.
No, the last one they broke it up for you in bite-sized pieces. This one you have to cut your own food. You have to figure out how you're going to do it. Okay?
Awesome.
I did. I do sometimes. I walk through prom and, can you cut my steak? Oh, no, I'm kidding. All right, there we go. Some people still cannot cut their own steak. I'm not going to name names, but they're in this room. All right. Huh?
I cut my own steak.
When have they ever served steak at prom?
We had chicken fried steak.
Back in the day.
Back in the day.
I wish they still did. Okay, I really don't know how to do this.
You don't?
Is it -3 times all that stuff? So it's -15x.
Now, before you start running around, what is the outside function going to be? Something to -3 power. Something like u to the -3 power. What's the derivative of that? -3 of something to the -2 power. Right. It would be -4, sorry. So it would be -3 parentheses to -4 power. That's the derivative of the outside. You have to multiply it by the derivative of the inside. Okay? Kaylee, is that what you got? Kaylee Bensel, is that what you got? I said, what did you get for your answer? Oh! I hope so. -3 times 5x squared minus 2x plus 1 to -4. There should be a 4. And then I have to take the derivative of the inside. I can do it in one step, but I just wanted to show you that there are two separate derivatives. Oh yeah, and this also means the derivative of the term immediately to the right. Okay? So I'm going to take the derivative of this and multiply it by the first one. It means you're going to take the derivative of the term immediately to the right of it. It's like a square root sign.
Why are you taking a derivative of that?
Because I haven't taken the derivative of this inside yet.
Like, why are you taking a derivative of that?
Because that's the inside of the parentheses. So that's going to give me the 10x minus 2 when I'm done. Okay? This first part right here is like the dy du, and this one's like the du dx. You can't multiply the 5x squared minus 2x plus 1, but you can multiply the negative 3 times the 10x minus 2, or you can factor a 2 out of the 10x minus 2. Probably factor a 2 out since you're going to be solving these eventually.
So the negative 6.
Oh, this is easy as far as solving. Yeah, and this is a 4. And that would be your final answer. There's no plus sign. There's no product rule because there's 9 variables multiplied together. And that's your final answer. Which one? I factored a 2 out of the 10x minus 2.
Why would you factor it out just to simplify it?
Yeah, and you're going to solve it eventually. Right. Five minutes?
12 minutes. But
Oh. Ready?
I'm like, can we do it? No, it really is.
What? We'll see.
No,
We should do this first.
we're not going to have time to do this.
We are. Don't sell yourself short. Quiet, please. This way, Grizz. You're the only one turned around facing that. Try this one on your own, start to finish. No, it's not working.
Yeah, so much time.
Give us like one.
All right, now you're all done? No, I'm kidding. I'm getting ready to give you your quiz.
Quiz? Is it a 1 for 10?
No.
10 minutes?
Shh. You're supposed to be doing this problem. Then try it really. Let's see, 3, 3, 3, 4.
We should do 1.
Quiet. Did you get it?
We got 2 answers, so I think so.
Well, I would say so. Did you get it? All right, Nick, what'd you get?
16 times w to the 4th minus 8w squared plus 15 all to the 3rd times w to the 3rd minus 4w.
Sounded good. W at the end.
Oh, you did W.
Well, you could have a W cubed and W here, but I took the W, the 4W out. That's fine. Well, because when you start solving these, you're going to see that W equals 0 and this equals plus or minus 2.
Why not just take it again? Because there's not.
Because there's a cube.
Oh,
Okay? How'd that go?
I did. I got it, but I just took the W out.
Great. Oh, we do.
If I know really
I never did that.
Page 125.
Use this piece of paper that I found.
Oh, ye of little faith.
And just not this.
Oh, this is number 14. So get through 1 through 15 odd for tomorrow. Page 125. Ready?
No.
Yeah.
So, really? Or 4.5?
We're doing a 2%. Oh my gosh.
Oh no. This is part one. We do this in stats all the time. We take parts of quizzes.
Oh, for like finish the parts. Like
Yeah, we're gonna finish the parts like tomorrow or Monday.
My next round, right? Do you know what round?
Oh, I gotta stop this, otherwise Kyle will be all confused about the random chit chat.
Yes.
I think so.
So, do you know what number we're going to tomorrow?
I don't know. I'll check.